Hello everybody, welcome back to the video. Today we will do Leetcode weekly contest 484. Good luck and have fun. We got 30 seconds left. See how much rating we will gain this contest. We will be competing in C++. Okay, the strategy today is just a normal ABCD. If something hard, we'll skip. Let's see how much we get. Join now. Okay. Hopefully it's not crashing. Looking good. Let's see. You're given a string S. Okay, a prefix is called a residue if the number of the string and the prefix is equal to the count of residue. Okay. Okay. Simple. Nothing too fancy. Hey, it is a residue too. Mod 3. Mod 3. Damn. 2, 1, 2. Submit. Okay, first one. Num subarray is going to center. The sum is equal to at least one element of the same sum. Wait, what? The sum of its element. See, wait, what? This is equal to at least one element within that subarray. Oh, I suppose. Term the number of centers. Okay. Oh, this is interesting. Pretty easy, I suppose. We just brute force this thing. Let's insert HA and it has dot count. Okay, what happens? 5, 2, looking good, submit. Okay. Words and string. Okay, choose either S or T, replace. Okay. Count the number of pair IJ such that choose either S or T, replace every. Okay. This is kind of weird. CA. Okay. This. So we got 2 string and. Yeah. Okay. Got it. How do you do this is kind of merge them. Really not. A into B. Wait, what? Choose either SOT, replace every letter in the chosen string. Wait, how many operations can you do? You can do it any number of times, so why isn't it true for every pair? This one is similar because you can do that. Wait, what? Oh, every letter. Okay, every letter. Okay. I thought it was like one letter, one type of letter. But every letter is very easy. Okay, how do you do this? So, are they the same length? Wait, what? Oh, they are the same length? Okay. So I suppose you do something of kind of hashing it. Hashing it. Std. Yeah. Map string. MP of X. Yeah, okay. V, right? Then CH is equal to CH minus A, and you plus J for the shifting, then you mod 26, then you plus A again. P of V, otherwise 0. Suppose that's just it. 1, 2. It's looking good. It's looking good. Is that enough? Any overflow? No. No, nothing. Nothing. Okay. To increments. I'm given 2 integer array nums and k and m. At most k operations and one operations. Choose the next I and increase nums of I by 1. Of any subset of size m after performing up to k. Ooh, this is hard. I think I suppose that okay, this is kind of hard. I'm not gonna lie. What 20? It's GPT-able, dude. Man, I hate this. Okay. Increase it by 1 will Whoa. Shift something upward. And so I think you can binary search on the number of bits, right? And you can ask if you can form this specific prefix with length greater than or equal to m. And yeah, that's what I'm going to do. Initial bit is equal to something. $30 is safe enough. I don't know. I know. So when I ask this bit, can you turn this bit on, right? If okay, if okay of result, then you can continue. Otherwise, you turn it off. Okay. Can this num call it x? Can we make this prefix? Right? That would be kind of a cost. So I would say something for auto x and nums cost vector initial cost. Okay, I see how to do this now. Then subset of size k. Okay, got it. So how do you do this? So you have this kind of prefix and you want to make it. Okay, how do you do this? To make it have these bits. If it doesn't have this bit, you will. For initial j is equal to b minus 1, j is this. If something, if x, j, if x has this bit, right, you have to you ask if x have this bit, you can just continue. Otherwise, something is going to happen. You would now j minus x. And it's very safer to do this because sometimes they overflow, even if it's int. Is that good enough? Well, now you're going to, yeah. So you turn this bit on, you ask, is x then, yes, not really good to do that. So then, then what? Yeah. Now it's just now it's equal to x. What is going on? Minus x. Because, yeah, you want to make it up this guy, and then you can safely break. Is that good? Yes. Push back now. Sort begin cost and cost. I think it's something like this. Is that good? Okay, something really off is happening. Okay, something really off is happening. Continue. Push back now. Oh wait, no, maybe yes. This because you do want that bit to be on. Okay, something weird is happening. Okay, so when you look at this bit and guess X has this bit, right? Now if this thing have this bit, you can safely continue. Now it doesn't have this bit, meaning the suffix of X from J to 0 need this bit on. So you're going to yes. Why isn't it working correctly? This is so weird. Oh. That's stupid. So we got 6, 4, and 2. And submit. Oh, wrong answer. Is there any overflow? Overflow. No. So when I look at, okay, what? I got 3 cases. This is weird, ain't it? At most k operations in one. Choose any index I and increase it by 1 of any subset of size m. Did I miss something in here? I don't get it. I don't really get it. Okay, let's check for overflow, right? Maybe 31. Not even sure, dude. Maybe 31. Cause, oh, okay. That is so weird. Okay, yeah. Yeah, because, okay, that makes sense. Okay, I'll go over the questions right now. Pretty, chill contest, I believe. So for Q1, it's just you do what the problems say. I think you just do Yeah. Q2 is, yeah, you do what the problem say again. Just this. Okay. Start from Q3 is interesting, right? Q3 is, yeah, I misread a bit, but it turns out not that bad. Yeah. So you have S and T, I don't know, A, B, C for S, and T is what? Let's do D, E, F. This is T. And you ask whether you can do this correctly by it's like a rotation. Yeah. So you either in one step you choose one of them to plus everything to the next character. So if you choose A, it's going to be B, C, D, right? Yeah, this stays the same. So in this one is saying choose either S or T, but actually in the optimal case, you just want to choose one of them to do it. Because if you choose two of them like alternating, they keep on looping forever. So just choose one of them and yeah, that's it. And what is the how to do this efficiently? Actually, it's very simple. You just solve for each rotation. It's kind of like two sum. You just solve for each rotation from 0 to 26. And you just hash the string, transform the string into this rotation, and check the map. Yeah, that's just it. Just put everything into the map. First of all, you're going to increase the thing. Then for each rotation, you're going to shift it, right? This is just how you shift it in C++. You check it. Yeah, that's it. For Q4, let's do Q4. Q4 is interesting, but I think it's classic, I guess, that you have a you have K, and you have M. You have an array A, it's a vector, a list, numbers, and you have K, which is the number of operations you can perform. You have M, is we care about it later. I explain later. So you have K, a number of operations, and you have a list. And you want to maximize the bitwise and of any subset of size M, right? Yeah. So in one operations, you can increase any number of A, any number in A by 1, and you can use up to K operations. So like 3, 1, 2, we have K is equal to 8 and M is equal to 2, right? Yeah. It's saying that you choose this one and this one. How does it work? You um, increase this to 6 using 3 operations. So increase to 6. This one is kept as 1. This one increased to 6 as well. And any subsets of size 2. So just choose this and this. Yeah. And these two and is 6. So the answer is 6. Okay. Simple enough. Now, how do you do it, right? Brute force way is what? You generate all the DFS of what? N plus K minus 1, choose K, time complexity, and that's gonna TOE. How do you do this? It looks very hard at the first sight, but you can do binary search on bits, right? So it works like this. You iterate from 31 to 0. Each operation, you minus 1 in the iterations. And you have a result. You turn this bits on. And you ask, is it okay? Like if you're in 0, if the current result is 0, 1, 0, 0, 0. All right, I'm going way too fast, I think. I'll go back a bit. So what? The if in the optimal answer, the result is what? 1, 0, 1, 1, 0, 0, 0. So obviously 1, 0, 0, 0, 0, 0, 0. If the result is this guy, then this guy is achievable, right? Because it is the subset of results. So you just work bit by bit. So you're going to turn this first bit on and you run some checks to see if the final result has this bit on. Then you iterate next time you turn this bit on, right? You turn this bit on and you ask, can I create a subset of size m using at most k operations to turn this bit on? And obviously, it's not a subset of results, so it won't be turned on. So you turn it off again, make it 0, and you go this way. You turn it on again, you ask, is it okay if I turn this bit on? And it's going to return correct, right? Return true for the checker. Now, how do you write the checker, right? It's actually really simple. So suppose you check if um, this mask is achievable, um, and the number in the array is what? Let's see. Say it's 0 right here. It doesn't have this bit on. 0 right here. No. Let's see. If it's 1 right here, 0, 0, 1, 0, 0. Okay, yeah, this works. So this is the target mask we are looking for. This is X in A, right? So you iterate from the MSB, what is it called? Max significant bit, something. I forgot the terms. So you iterate from 31 to back to 0, right? You check if this bit is on. You must like turn this bit on somehow, right? Oh, okay. So in that case, I think. Oh, okay. Think. Let me think. I think you don't need this. Um. Huh. Why did that happen? Why did that happen? Oh yeah. That's true. That's true. Yeah, I have to skip. Okay. Yeah. I don't know why I was thinking I can't I can't skip. I cannot skip. Okay. If they have this bit on, right? You kinda not want to turn like you kinda not want to touch anything in the original X and A. Next one, you're looking for this one. It's 0, so you don't need to do anything. Now the interesting part come to this guy. The target has this bit and X doesn't have this bit on, meaning you have to increase every suffix of this to match the mask of this thing. And that is the cost. That would tell you the cost of every number to increase to have X, to have the target as a submask of X in A, right? And then, yeah, the rest is very simple. You have the cost, and now you have the array cost. Now you just sort it and iterate over from 0 to m and subtract the cost out to see if it's doable. Yeah, that's it. I had a mistake in implementing, and I was doing 30 instead of 31. It's normally 30 is enough for 1e9, but in this problem, it's 2e9 actually. It's 2e9 because you have nums and you have k, so it's 2e9. So 31 is the safe bound. Now, yeah. So I was talking about this earlier. You iterate and then you turn this bit on. You ask, is it okay? If it's okay and I can continue, I can keep this bit on. But if it's not okay, I'm going to turn this off. Now for the checkers, you just do, yeah, you cost. Iterate over this. Now if x is the target, if this if it has a target and x has this bit, you just want to skip it because why can't I be I tried it earlier. I removed this because I thought it works no matter what. Actually it doesn't. Let me show you the case. um it's in here actually. um X. If I do see, this bit is 1. Now if I say that I have this bit, okay, I don't check this one and skipped it, it's going to um ask how much do I transform this submask into this submask, and look at this one. This one makes the cost more, or maybe be negative. I don't know, but yeah, it's just wrong. You have to skip it. Now x does not have this bit, meaning you have to match the suffix onto the target. You turn every bit, so it's like 1 1, right? Yeah. To now you extract the target bit from J, then you extract the X bit from mask 2, and then you got that. Yeah, that's it. Yeah, I think that's good to go. I'll stop the video here. Let me know if you have any questions in the comment. I'll reply to you later, and peace.